The limitations that you have to fight when you want to build lightweight clients, mobile clients. So this again, this is how mobile clients work. You scan payment requests. You have a view of the network that is supposed to be good enough. You compute the routes. You create an HTLC. You get a pre-image back. You've paid. So a Lightning node is a Bitcoin node, as in you have to be able to create, sign, and send Bitcoin transactions on the Bitcoin network. You have to be able to monitor the blockchain to detect when a funding transaction has been spent. But you also need to maintain a routing table that you use to compute payment routes. And it has to be good enough. It doesn't have to be perfect. It has to be good enough so that your payments will not fail. And on a mobile phone, it's a bit of a challenge. So the first part you need to implement is a Bitcoin wallet. So I assume that you can't really have a full node on your phone. I know that some people are working on it, but I'm not sure it's realistic right now. So you need to choose an option. And you don't have that many options to choose from. So you can use Bloom filters. Do you all know what Bloom filters are? BIP37, okay. You can use Neutrino. You all know what Neutrino is? Very impressive. Why? Okay, so let's check. Why do we call Bloom filters server-side filtering, and why do we call Neutrino client-side filtering?
Computation is pushed to the client.
Okay, so suppose I'm a Bitcoin node and I support BIP37, and there are not that many of us left, and you're all BIP37 wallets. What does it mean? That's yeah, that's exactly. It's a bit of a mess, because if I have 200 wallets connected to me, I have two different filters to juggle and match, and it's a bit of a mess. Neutrino is very different. It will give you a very compressed view of blocks, but it's a compressed view that you can query for things. So basically, you will get the filters, and you will filter for things that you want on the client, which is why it's called client-side filtering, and which is why it's way better. You don't reveal information about what you're interested in. That's the two basic options if you want to implement everything on the client. You could use an API. A lot of people use APIs. I think that's what Ledger is doing with its wallet. I don't know about Treasure. Which means you need to roll on your own servers, and people need to trust you to some extent. Or you could use Electron servers. So who knows a bit about Electron, the protocol, and how it works? Okay, so I know that Electron is not really popular now because of the phishing attack they've been fighting for like months, and yeah, but it's Python, blah blah blah. But it's very, very clever. The Electron protocol is very, very clever, because what is missing in Bitcoin Core are indexes. Okay. I would say that if you compare, it's recorded. Okay, if you compare Bitcoin to Ethereum, I think one thing that Ethereum, I wouldn't say they get it right, but that's why people think they get right is with Bitcoin, a lot of the complexity is pushed toward the clients. If you want to work with Bitcoin, if you want to get information for Bitcoin core nodes, you have to do a lot of work yourself. A lot of work. If you want to implement a wallet, building a wallet is much, much harder than it looks. I don't know if you think it's easy, but it's really hard, because you have to do a lot of work on the clients. Ethereum, it's the opposite. Basically, it's very easy to build a wallet because it's a balanced system and not UTXOs, and basically building an Ethereum wallet is very simple. And what you need when you're building wallets is basically an index. You need index information. What are my UTXOs? Have they been spent? And this is something that is really hard to get, almost impossible to get with Bitcoin Core as it is today. And I did once, I think it was 2 years ago, ask the core devs to add a spent by index. But that's why we chose Electron, because Electron basically it's like it will give you a lot of indexes. It will index your. The protocol is really clever. It indexes script hashes, as in hashes of pubkey script. So it doesn't really matter if it's SegWit or not SegWit. You will really be able to quickly find information about your UTXO, your transactions. And we started with Bloom filters with BitcoinJ, and don't work with BitcoinJ. We gave up after a while, and we switched to Electron servers, and we were fairly happy with that choice, even though we are looking at Neutrino, because Neutrino is a really nice model, but we think that it will not be as efficient when it comes to bandwidth. Neutrino will probably get you to download a lot of data, lots of blocks. Electron is extremely efficient in many ways. Yes, because of the phishing attack. I'll talk about the phishing attack on Electron because it's beautiful. I'll talk about this.
Oh, so it's you guys.
It's really a nice attack.
But privacy-wise, does the Electron protocol just send around expops or individual addresses, or what is it?
You tell it, I'm interested in these script hashes, and it will give you the history and transactions that are connected to these script hashes. So basically, yes, it knows. That's one of the issues with the APIs and Electron. The servers know a lot about your UTXOs, and if you use, and that's what we do right now, if you use the same servers to retrieve information about your UTXOs and to publish transaction, then they really know what is yours. So yes, it is very likely that some analytics company are running Electron servers. But you can use Electron over Tor, which is like mitigates a bit the issue. Monitoring the blockchain is difficult on a mobile phone because they will be offline very often. So if you're offline and if your peer publishes an old state, and if you miss the penalty window, you will lose money. This is why, again, L2 is for us a much better solution because that problem goes away. So you have two options. You can use really long timeouts, but when your channel gets closed, it means you need to wait a long time, like 2 weeks, before you get your money back, which is, again, really hard to explain to newcomers. Or you can delegate blockchain monitoring to a third party. That's the Watchtowers. But okay, so something I should have mentioned. Today you have three types of mobile wallets. You have like the full nodes that we try to push. You have remote controls, and you have custodian wallets. Remote controls, if you can run your own full node and lightning node and connect to it, then yes, you have less privacy issues. You have a really specific security issue. It means that there's a server somewhere running either in the clouds or in your closet with an API to spend money. There's something that we used at the beginning. We don't use it now, but I thought it was really nice. There's one case where you don't need Watchtowers or to monitor the blockchain at all. It's when you're only sending money. So do you know why you don't need to monitor the blockchain if all you do is pay? Yeah, because the old states will be in your favor. So it doesn't really make sense for the other guy to publish an old state. And if they do, why not? More money for you. But so that's why for a very long time we didn't have the option to receive money.
Well, so, I mean, you could still make more by punishing them, though.
Yes, but then not having to monitor the blockchain was a huge gain for us. So when we started, we had a really small timeout delay, and you could only pay, which was, I think, really good for UX. So Watchtowers, are you going to have a specific talk on Watchtowers? No. Okay, so I will explain. Since we have the original author of Watchtowers with us, I will try to explain the Watchtower ID. Basically, you delegate monitoring the blockchain to someone else, but you don't want them to learn anything about what you're doing. You don't want them to learn what your channels are, what your payments are. And basically, the Watchtower is supposed to react when your peers publish an old state, and the Watchtower will publish the penalty transaction. One of the first Watchtowers design, which is really nice, is you send a Watchtower a penalty transaction for each commitment transaction that you sign, and you encrypt the penalty transaction with the first or the last, it doesn't really matter, one half of the commit transaction ID. And the Watchtower only knows the other half of the commit transaction ID. So basically, the Watchtower is looking at the blockchain, and they try to see if there's a transaction that spans a transaction. So if there's a transaction which that has an ID that matches the 16 bytes you gave it, and if it sees one on the blockchain, it uses the remaining bytes to decrypt what you gave it. That's a penalty transaction, and it publishes the penalty transaction. So that's really elegant. It's really nice. The Watchtowers, they don't know which channels they're watching. And if no one tries to cheat, Watchtowers learn absolutely nothing. All they have is encrypted data that they can't really make anything with it. But there's a huge problem with that. You need to store a never-increasing amount of data. And that's a big problem because you will have to pay for that. For example, what's the difference if you're using cloud providers? What's the difference between buying virtual servers, CPU-wise, and buying storage? Why is it a bit cheaper to buy? Why do you have cheap options to buy CPU, but you don't have cheap options to buy storage? Exactly, because cloud providers will overbook. Basically, they know that you won't be using your CPU 100% all the time, so they can overbook CPU allocation.
If you go to Amazon, like if you do a backup, you only pay for the data that you're actually.
Yeah, but if you want to use block storage, even if you want 300 gigabytes and you use 10 of them, you're going to pay for 300 gigabytes. You can't really overbook storage, so it's not cheap to implement Watchtowers the way that with this particular design, because you're giving an interface for people to write onto your disks. So that's really hard to incentivize. Exactly. L2 again. With L2, it's a huge change. With L2, all you need to remember is the last state. That's it. So now I come to the other UX issue we're facing, especially on mobile phones. The first one was stuck payments. It's the biggest issue for Lightning, I think, right now. The second one is not that much of an issue, except if you want to build like web wallets, is how to get a good view of the network. So this is something you've already seen many times. Source routing works because you need to have a good enough view of the network to compute the onion packets. And if your view is not good enough, you will get the updates that you're missing because you computed the fees wrong or your CLTV deltas are wrong, but your first payments will be slow. As you learn the updates, when you receive error messages, your first payments are slow. And it's something you can actually see. If you use Eclair and if you haven't used it for a few days, you start and you try to pay, you will see that the first payments are slow because we're failing. Actually, what's happening behind the scenes is we're failing. We're learning about new updates and we're trying again with the new updates. It's bad UX. So what you want is to be able to have a really good view of the network as quickly as possible. So that's what we call the routing table synchronization issue in Lightning. The first version was extremely basic. You download everything every time you start. So it was very efficient for mobile phone. It became very inefficient for everyone, so we're not using that anymore. The second version was you download all the channel IDs that they have, you compare against the ones you have, and you ask what you're missing. But this too was not too efficient. So we've proposed, it's not been merged yet, to add timestamps and checksums to the filter queries to make filtering more efficient. You can avoid downloading channel updates that are older than the ones you have, and you can avoid downloading channel updates that carry the same routing informations as the one you already have. So that's something that we're working on right now. And a lot of people think that set reconciliation techniques like inverted Bloom lookup tables or mini-sketch could be applied to that problem. Basically, you have two nodes with two routing tables. How do you use set reconciliation techniques to synchronize their views of the network? I'm not convinced it works. I know that Matt is absolutely convinced it should work. So one way of fixing this is to just not compute routes on your phones and delegate routing to another server. It's implemented by, what's its name? Lightning Simple Wallet, Bitcoin Lightning Wallet. Bitcoin Lightning Wallet. It's pretty bad for privacy because basically that node learns who's paying who, and I think that's pretty bad. It defeats the point of using source routing. And the last slide is about implementation issues that are specific to mobile platforms. Basically, everyone asks us when we're going to have a wallet for iOS, and it's currently not possible because there are no JVMs for iOS, and it's really, really hard to have one because, for example, JVM uses just-in-time compiler. It will generate executable code from bytecode, and this is something that Apple doesn't want anyone to do. They don't want people to generate executable code from data. So we're not going to have an iOS wallet for some time unless there's a breakthrough somewhere. And Android is stuck at Java 1.7, which is obsolete for most cases. So that's it's a bit of a problem now. We think Google will fix it, but it's getting a bit difficult. I think that yes, they have a future. We have lots of ideas on how to improve UX. We have I don't know how many users. I think it's 20,000 for the Android wallet, which is not too bad. And more importantly, I think if we have to make sure that we can build mobile wallets. If we give up things on the Lightning specs so that it becomes impossible, then we will have lost something that is really important. So we still want to push the ability to build mobile wallets, even though some people may prefer to use remote controls or custodian services. Obviously, onboarding with custodian services is much, much better. But we need to be able to build mobile wallets.